Top 5 Big Data and Analytics Trends in 2021. In our very changing society today, data analytics have played a vital role in the way we manage and process big data. As a result of constant advancements and digital transformation in technology, big data and analytics initiatives have improved and created endless opportunities like self-driving cars, robots, autonomous delivery drones, and so on. None of these would be possible without data, the oil of the fourth industrial revolution, and the analytic technology we've built to allow us to interpret and understand data. Big data is a term used to describe the advanced technology and practice of working with large data sets in different forms and size. Hey, for more data analytics trends, make sure to subscribe to my YouTube channel to be notified on future videos. Some key trends that will influence how data and analytics are used for work, play, and everything in between this year and in the near future are: 1. Adoption of AI to improve deeper insights and increase automation. Artificial intelligence, also known as AI, has been a game changer for analytics. With the huge amounts of structured and unstructured data generated by companies and their customers, even automated manual forms of analytics can only scratch at the surface of what's to be found. The simplest way to think of AI as it is used today is machines, computers, and software that are capable of learning for themselves. Interpreting, understanding, and drawing insights from all those datasets is a far more complicated task. AI is very useful here because it can attempt to interpret the data and come up with predictions. It provides a range of probabilities and then refines its result depending on how accurate those predictions turn out to be. Number 2. The rise of data ops and data stewardship. Data ops is a method and practice that borrows from the DevOps framework, often deployed in software development. While those in DevOps role, manage ongoing technology processes around service delivery, data ops is concerned with the end-to-end flow of data through an organization. Rather than thinking about data in piecemeal fashion with separate people dealing with data generation, storage, transportation, processing, and management, data ops processes and frameworks address organizational needs across the data lifecycle from generation to archiving. The evolution of the role makes it a great opportunity for anyone with experience or interest in an IT career and wants to work on the exciting or most exciting and innovative projects, which are often data projects. We also see the growth in popularity of data ops as a service. Vendors offering end-to-end management of data processes and pipelines on tap and pay as you go. This will continue to lower the barriers of entry to small and startup organizations with great ideas for new data-driven services, but without access to the infrastructure needed to make them a reality. Number 3. Data management processes will be further augmented. Data visualization is the final mile of the analytics process before we take action based on our findings. Traditionally, communication between machines and humans is carried out by visualization, taking the form of graphs, charts, and dashboards that highlight key findings and help us to determine what the data is suggesting needs to be done. The problem here has been that not all people are great at spotting potentially valuable insights hidden in a pile of statistics. As it becomes increasingly important that everyone within an organization is empowered to act on data-driven insights, new ways of communicating these findings are constantly evolving. One area where important breakthroughs have been made is the use of human language. Analytics tools that allows us to ask questions of data and to receive questions in clear human language will greatly increase access to data and improve overall data capabilities in the organization. This field, is known as natural language processing or NLP. Number 4. Hybrid cloud and edge. Cloud computing is another technology trend that has a massive impact on the way big data analytics are carried out. According to Gartner, public cloud services are expected to underpin 90% of all data analytics innovation by 2022. The ability to access vast data stores and act on real-time information without needing expensive on-premises infrastructure has fueled the boom in apps and startups offering data-driven services on demand. But relying entirely on cloud or public cloud providers is not the best model for every business. And when you trust your entire data operations to third parties, there are inevitably concerns around security and governance. Many companies now find themselves looking towards hybrid cloud systems, where some information is held on Amazon Web Service, Microsoft Azure, or Google Cloud Service, while other, perhaps more personally sensitive data, remains within the proprietary walled garden. Cloud providers are increasingly on board with this trend, offering cloud on-premise solutions that potentially provide all of the rich features and robustness of public cloud, but allowing data owners full custody of their data. Edge computing is another strong trend that will affect the impacts of big data and analytics, on the lives in the future. Essentially, this means devices are built to process data where it is collected, rather than sending it to the cloud for storage and analysis. Some data simply needs to be acted on too quickly to risk sending it backwards and forward. A good example here is the data gathered from sensors on autonomous vehicles. In other situations, consumers can be reassured that they have an additional level of privacy when insights can be gleaned directly from their devices without having to send data to any third party. For example, the Now Playing feature on Google's new Android phones continuously scans the environment for music, so it can tell us the names of songs playing in the supermarket or movies we are watching. This wouldn't be possible with a purely cloud-based solution, as users will reject the idea of sending a constant 24/7, stream of their audio environment to Google. Number 5. Data engineering relevance for sustainable machine learning initiatives. Empowering application development teams with the best tools while creating a unified and highly flexible data layer still remains an operational challenge for the majority of businesses. Hence, data engineering is fast taking the center stage, acting as a change agent in the way data is collected, processed, and ultimately consumed. Not all artificial intelligence or machine learning projects undertaken at an enterprise level are successful, and this mainly happens due to the lack of accurate data. Despite making generous investments in data analytics initiatives, several organizations often fail to bring them to fruition. Yet, companies also end up spending significant time preparing the data before it can be used for decision modeling or analytics. Here, data engineering makes a difference by helping organizations harvest clean and accurate data that they can rely on for their artificial intelligence and machine learning initiatives. Thank you for watching. To be notified on future technology videos, subscribe to my YouTube channel.